So next we have the triangle mid-segment theorem. Triangle mid-segment theorem that states that a mid-segment is parallel to the third side and is half its length. Okay, so we're going to use that half piece. So in the triangle above, so again referring back to this one, XY would be parallel to RS. Okay, so these are parallel. That's what those arrows indicate. And XY would then equal 1/2 of RS. Okay, or you could take RS, so that entire length, that bottom length there, and divide it by 2 in order to get your mid-segment. So you just need that bottom length of that triangle, the one that's parallel to the mid-segment, divide that by 2 to get your mid-segment. Okay, so a couple of examples of this. It says JH is a mid-segment, meaning for each one of these problems, J and H are midpoints of those sides. Okay? We want to find the value of X in each case. So we're going to use this triangle mid-segment theorem. So JH here is where X is. That's the mid-segment. Which side of my triangle is parallel to JH? Which one? LM. Okay? So since that is my parallel side, I can take that length of 30 and divide it by 2. And that will give me JH, which is 15. Okay. Looking at the next one, number 2. So this time I'm given JH is 9. Now my parallel side to JH is still LM. Okay, but this time my X value is LM. So instead of dividing by 2, because that would give me the mid-segment, what should I do to find that total length there? Times by 2. So to get X, we'll take 9 times 2. And LM, or X, would be equal to 18. Shh. Talking stops, please. The last one here, JH is right here. That's what we're looking for. Okay. LM is, again, the parallel side. Now this point right here, it doesn't say it, but these are congruent to each other. So if this length is 8, this length is also 8. So all of LM is 16. Huh? This is 8. This is 8. Yes. Yeah. So to get X, we're just going to take that 16 and divide by 2. To get X is 8. So mid-segment theorem, not so bad, right?
But then it gets worse.
No, you're just setting up proportions. All right, so the next part here, we have the triangle proportionality theorem. So in any triangle, A line parallel to one side of a triangle separates the other two sides proportionally, and that converse is also true. So, in my picture here, if I know XY is parallel to RS, okay, so XY and RS are parallel. Again, that's what those arrows indicate. Then I can set up equal ratios. So with these parallel lines, I can set up a ratio of Rx to XT. Okay, between my parallel lines, I had Rx over XT. Or I could say Ty over Ys. So instead of going this way, I just went the opposite way. Okay? Or I could set this up as, again, starting with Rx, but instead of going to XT, I could use the entire segment as well. So RT. Okay, so these are just different ways to write your ratios. So I'm going to do the same thing below with these parallel lines here. So we're going to draw in, guys, I really need you to stop talking. I'm going to draw in two lines intersecting all three of those parallel lines. Okay, so these are all parallel. And I'm going to label each segment differently. So this segment here, from this point to this point, I'm going to label as A. Okay, so that's segment A. And then that bottom one there, from that point to this point, I'm going to label B. Then over on this line, we have segment C and segment D. So what I'm going to do is set up equal ratios or a proportion using these two lines. So I can set up a proportion using A and B as my first ratio. So I can say A over B is equal to my other side in the same order, C over D. Okay, so since I started with A, that was between these first two parallel lines here. Then I need to start with C in my second ratio because it's between those same parallel lines. Okay, then I went to B between these two, which is equal to D between those two. Okay, so that's one way. Or I could set this up as A over C. Okay, so A over C, what do you think that one's going to be equal to? B over D. Good job. Okay, so since I started with A to over C, I then had to start with B since that's in the same line as A over D. Okay, the last one that you could write, so again, with these problems, there's multiple different ways you can write these proportions. So it's whichever way you feel more comfortable. The last one, I'm going to need my entire segment here. So if I combine these two, what would that be? Not AB. No. If I said A was 1 and B was 2, you would say it's 3 because you did what? You added them. So this should be A plus B. Then over on this side, we're going to do the same thing. That is C plus D. So I can also set up a proportion using one of my smaller segments. I'll just use A over its entire side here, which was A plus B. Okay, then my second ratio that it would be equal to, since I started with A here, I'd have to start with C in this line. So that would be C over its entire segment there, which is C plus D. Okay, so these are the different forms that your proportion can take with these parallel lines. And when we set those up and solve those. Okay, any questions on that so far? All right, then we can also take the converse of that. So what the converse of that says is if you have equal ratios, so you're already given each side of that triangle or with those parallel lines, and you reduce each of those ratios down just like we did before to prove similar triangles, they're equal ratios, then those lines have to be parallel. And you can say those lines are parallel. So that's just what the converse is talking about. So we are going to go over an example of setting up these proportions to solve for a variable. So in example 1 on the back here, we have triangle ABC, okay, ABC, where EF is parallel to CB. And we want to solve for X. Now just like I said before, we could set this proportion up multiple ways. So one way, since these are my parallel lines, I could take my smaller part here, which is 6, over within the same line, that larger part is 18, right? Okay, that would be equal to, now I'm going to go to the other side. Since I started with 6, I should start with that smaller side in the other line as well. That's x plus 2. So I have x plus 2 over the larger side within the same line, which is x plus 22. Okay? That's one way to set this one up. Another way you could set this one up, you could set it up as 6 over x plus 2. So I just took the two smaller pieces and set it equal to that same ratio of the larger pieces. So since I started with 6, I'll start with 18 in this proportion or ratio here. And then over x plus 22. Okay, so you can do it that first way or that second way. Okay, either way you're going to get the same answer. So if I just do it this way here, this is a proportion, so we just have to cross multiply. Okay, so I'll take 6 times that quantity, x plus 22. Okay, that's equal to these two multiplied together, so we have 18 times x plus 2. Remember, you do need to distribute this 6 and this 18. Okay, so 6 times x is 6x, and then 6 times 22 is 132. And on the right there, multiply 18 to both terms. So we have 18x plus 36. Okay, from here I'm going to subtract 6x. So I have 132 equals 12x plus 36. Subtract 36. I have 96 equals 12x. And then divide by 12 to get x is equal to 8. And if you would have done it that first way on the left there, you've gotten the same answer. Okay? So, again, multiple ways to set up this proportion. Questions on example 1. All right, example 2 has to do with the converse. Okay? So that converse theorem at the top there. So in triangle GHJ, HK is 5, KG is 10, and JL is 1/2 the length of LG. So if I were to label LG X, and I know JL or LJ is 1/2 that length, it would be 1/2 X. Now, what I want to do is see if HJ is parallel to KL. So I want to see if my ratios are the same when I reduce them. So we're going to pretend like these are parallel to see if they actually are. So I want to set up that ratio. So I'm going to take my smaller one of 5, so that's HK, over my larger one here, which is KG, and that is 10. And I'm just going to reduce that. So if I have 5 over 10, 1/2. Okay, so the ratio between those two sides is 1/2. So we're going to do the same thing for our other side. So since I started with my smaller one here, I'm going to start with my smaller one on this side as well. So that is LJ over LG. Okay, so LJ is 1/2 X over LG is X. Now if I have an X over an X, what happens? They cancel out. So it's only 1/2. So are those two ratios the same? Yes. So since ratios are equal, HJ is parallel to KL. So that one you were just proving that those two lines would be segments would be parallel to each other because they have equal ratios. So if they weren't equal ratios, you'd say they weren't parallel. Questions on example 2? All right, then looking at example 3. Okay, frontage is the measurement of a property's boundary that runs along the side of a street, lake, ocean, or river. Find the ocean frontage for lot A. So if I look at my picture here, the ocean's here. My ocean frontage would be this length right here. So that's what I want to find. That's what I'm going to label X. So if I look at my picture really close, I can see these little arrows in each of these lines. What do those arrows mean? That they're parallel. So I can set up a proportion because those lines are parallel. So just like we were doing before, I can take this section X, or from lot A. It can go over that section from lot B. That's equal to what ratio then?
58. Sideways.
I knew what you meant. It would be 58 over 42. So since I started with lot A, I should start with lot A again. Went over lot B, so over lot B on that other side. So from here, now that I have my proportion, again, all you have to do is cross multiply. So we have 42 times X equals 60 times 58. Divide that by 42. It is 82.9 yards.
Yes, it went.
Okay, so just like we were doing in our previous lessons, setting up the proportion and then you're solving it. I want you guys to do 1, 2, and 3. 1, 2, and 3 in the next problems. I'm going to give you a hint. Number 3 is a mid-segment problem. That's what we did on the front.
Am I gonna remember this for the test? Absolutely not. Hey, I studied for my final. Actually. I took a big gallon of it.
Gallon of what?
Huh?
Gallon of what?
Oh.
Gallon of what?
PhD.
It's disgusting.
It's good. I have so much done. I like the red. I like the raspberry ice water. Yeah.
I like it when you milk.
This one's done.
My friend yelled at me for calling it strawberry milk. And then I took a picture of it at lunch today. She's like, oh my God, I want to fill this after. I'm like, bitch, you said I can't call strawberry milk, but you can. It's like, wait.
These are upside down. I realize that
I
yesterday.
don't know what you're talking
I have 7 upside this way.
Huh?
The pink milk.
Not really.
about. You're weird.
I like banana. Pink claw.
That's disgusting.
The banana milk, right?
Hmm?
Pink claw.
Mhm.
Those are good fish. It's like a pink. Oh yeah. Oh my God. They better be off by that. Your nails will be gone. You have 4 months.
It's for a school project. Don't worry about it. Go ahead.
Cynthia, I'm not gonna
Yeah,
What was that for?
that's, I don't know, some school project. I do want to, times. Oh no, you still have some time. Keep working.
Oh, man.
thought we were done at 19.
Yeah, we are.
Oh, no, we're done at 21. Yeah, I know.
3.
I doubt that. That's. We learn how to get homework. Oh, wait. Oh, yes, we do. I know.
I'm not gonna waste my time on no power. Really? Oh, I know what those are. You pull this and it tips up, right?
It's way too warm out to be going fishing on it. Like I said,
There's no point of going fishing on the mill pond anymore. You're not gonna catch anything. If you catch something, it's gonna have like 8 eyes or something. It's gonna have like baby
Do you
arms.
do your math problem? Well, that's not homework, it's just in classwork. Well, maybe if you did your in-class work.
I just say I don't know how to do it.
That's your words.
That's what I do in science. That's just
All right, I do want to start going over this now. So, this first one here, we're solving for x. All right, we're quiet now, please. So, the way I usually use the parallel lines in these problems, I use them as the fraction bar. So, if you extend it, you can split this into your fraction equal to this fraction. Okay? So I can take this piece of 5 over 5 equals this top piece is 7 over x. Yes. So from here you can cross multiply, or if you just look here, this fraction,
it's 1.
hey, this fraction, 5 over 5, has to be equal to this fraction. Well, 5 over 5 is 1, so what would 7 have to be over for it to equal 1? 7. Otherwise, you can just cross multiply, solve. You should still get 7. All right, we're going to do the same thing. Same thing in number 2. So again, what I do with the parallel lines, I extend it out to make that fraction from my 2 sides. Okay, so then I can just take this fraction equal to this fraction. Okay, so I have 20 over x, 20 over x equals 18 over 9.
I have 18 over x.
Wait, you don't have to have it exactly like that, do you?
No, how'd you set it up?
I have it like
I had 18 over x equals
20.
9 over 20. Well, I still have 40.
I have x over 20 and 9 over 18.
I still have 10.
X over,
30.
yeah, that works.
Okay.
So from this point, I'm going to cross multiply. So I have 18x equals 180. Divide by 18. And x will equal 10.
You divide that by 2 to get 17.5.
Yes.
Okay.
So number 3 is a mid-segment problem. Okay, so you could figure that out by looking at these congruency markers. So that means this point is a midpoint and this point is a midpoint. Since these 2 lines are parallel, You just have to take that longer bottom line and divide it by 2. To get x is 17.5.
No, my AirPods came with the charger. My AirPods came with the charger.
Sorry, I can't hear you.
Hey,
It's so stupid. Like, why-
so any questions on these 3 problems? All right, then we're going to go over the next couple here. So number 4, we're going to do the same process. Okay, we have these parallel lines. And we're going to set up a proportion to solve for y in this case. So just like I said in these triangle problems here, I use that parallel line as the fraction bar to set up my ratio. So since this line is parallel, I can use that piece as my fraction bar and this piece as my fraction bar. So I can take the ratio here and set it equal to the ratio here. So we have 5 over 8 equals, this fraction here is y over y plus 2. Okay, and again, I just have to cross multiply. So we have 5 times y plus 2 equals 8y. You do need to distribute that 5 to both terms. So we have 5y plus 10 equals 8y. Subtract 5y. Then divide by 3. And I'm just going to leave this as a fraction instead of dividing on my calculator.
Wait, you just leave it? Okay.
Yep.
I'm a disappointment.
No, I just didn't want the repeating decimal. Okay, so that was number 4. Questions on that one? Number 5. So this one's a little bit different. So I do want you to notice that all of these pieces here are congruent. Okay, so since these are proportional pieces, and if I were to set up, say I just made up a number for what this side length is, like 5. Okay, so I would say this is 5 over 5 equals this over that, right?
Yep.
If it's 5 over 5, that's just 1, correct?
Yep.
So when you see something like this, your pieces across have to be congruent to each other as well. Okay, so since all 3 of these are congruent, their proportional pieces have to be congruent. So to set up an equation to solve for x, I just have to choose 2 of those lengths to set equal to each other.
To be honest, I cannot do that.
Okay, so I can just pick those 2 pieces, 12 and 2x minus 6. Okay, again, because those are proportional to the other side, and those were all equal, that side also has to be all equal. So from here, I can just solve for x. So I have 18 equals 2x, because I added 6. Okay. Then divide them by 2. X will equal 9. All right, I want you guys to try the last two. Number 6, number 7. Remember what those congruency markers mean. It'll make it a little bit easier.
No. Why do we have X's and Y's in the same?
What do those congruency markers mean?
That they're the same.
They're the same, which means you can do what? Set them equal. If you ever see congruency
Yesterday, I was with this girl. Jason showed up and can't see what we were and I told Nick, and I'm like, Jason, put your hands like this. So he does it.
Good job, Sheila. You're on
Put your
top.
hands like this. Do it. Put your hands. I can't do it for myself if I need my hand. I'm not doing it. So he goes like this, I would go like this and like raise my hands. Probably enough time.
Where?
Activities.
No,
Well, this would be 12 times 5x.
Whoa. Sheila,
Probably either with medicine or hospital.
What? And he has small hands. Walking out.
I was gonna put George in that.
I don't want to go out of
I could literally live with my grandma on my hand. I sat at my uncle's house. Slept over. On the 15, I got 9.
All right, sit down. Quiet down for me, please. So for number 6, I wanted you to notice that these two pieces are marked as congruent. So to solve for x, you just have to set them equal to each other. Okay, so 2x plus 4 equals 3x minus 1. To get x is equal to 5. Now, since those two pieces were congruent to each other and you have parallel lines, that means the side on the opposite side over there with those parallel lines also have to be congruent to each other. Okay? Just like problem 5 above. Okay, so those pieces also have to be congruent. So I can set those equal to each other as well. So I have 3y equals 2y plus 2. Then just solving for y is equal to 2. Okay, then the last problem here. Quiet, please. Last problem here, I can set up my proportion just like I was before. I know most of you did it this way, I believe. So 5x over x plus 12 equals 3x over 12. So just those proportional pieces there. From here, I'm just going to cross multiply. So I have 5x times 12. Well, 5 times 12 is 60. And I still have that x. That's equal to 3x times the quantity x plus 12. I need to distribute that 3x. So I have 3x squared plus 36x. Now I'm going to get everything on one side. So I'm going to subtract 60x. So I have 0 equals 3x squared minus 24x. Now I'm going to factor out what they have in common. Okay, so those two terms there both have a 3 and an x. So I can take out 3x. What I'm left with is an x minus 8. So yes, you have to factor this one because you had an x squared and an x in the problem. Now all I have to do is set both of those equal to 0. So 3x equals 0 and x minus 8 equals 0. So in this one here on the left, you're not going to leave until I let you go, so stop packing up your stuff. And this one here, you'll get x is equal to 0, and this one here, x is equal to 8. Well, your side length can't equal 0. Okay? This side is 12, so this side cannot equal 0. So that cannot be your answer. So your final answer has to be x equals 8.
I got it. I got x equals 2. Oh, yeah, wait, 2. You got the 8. You didn't have the square root.
Okay? Tomorrow I'm going to have you guys